Let's code for a preorder, inorder, and postorder. So to do this, I have this previous class right here, class int tree. It has three variables. We have a public int data, public int tree node left, and public int tree node right. And this is for our tree when we need our left, right, and we also need our root. We have this constructor right here, which initializes our left and right to null when passed in a data value for our root, and then this one down here, which initializes everything data left and right. Going into our class int tree here, we are going to have a private int tree node, and we're going to call this the overall root. So we're making a new instance of this class int tree, and we're going to have the root be the overall root. It's going to store all of this information right here. Now, typically when we do trees like this, we are going to have a method to actually take in some value. It'll do something, we have a parameter, and again it will do something where we pass in the parameter and the overall root so that we can make changes to our tree. This is going to be done using recursion typically. It's the easiest way to kind of understand binary trees and as well as do them. This is going to be accompanied, this public method, with a private method. This private method is going to be what really does the heavy lifting. The methods and structure isn't always going to look like this, but they usually will, so it's important just to have this knowledge down. Now, let's code for our preorder. Remember, preorder is when we look at the root, then the left, and then the right subtree. So to code something like this, of course, we need a public void. We're going to want to have a method that our main method, if we wanted to, could call to print. So let's make it a public. It's going to be printing, so not returning anything. It's called a void, and we'll just call this print preorder. Outside of here, we'll make a private method, but first let's just make a call to it, even though it doesn't exist. We're going to have our print preorder, but we aren't going to call a void. That would be bad to continuously call a void. That's just a infinite loop. We're going to want to pass in the overall root. In doing this, it'll allow us to make the same method basically, but instead we're going to make it private, and then we are going to have it take a parameter, and this parameter is going to be overall root, and it's going to be of type int tree node. So this is what this header is going to look like. We can just take this out. We're going to modify line 42 in a second. Remember, preorder is our root left right. So inside of here, we're going to want to deal with the root first. But let's check to see if we even have to deal with anything. And the way we would do this is by saying if our overall root, and though it's called overall root in here, every time we do this recursively, remember we are going to have another temporary root. So every time we do this, we're essentially going to look from here down to here. We won't always be using the overall root, but we'll be describing this as the new root. So just for consistency on that, I'm going to change this to root. So if our root, because remember it changes every time we move down the tree recursively, does not equal to null, then we can start printing out and calling this recursion. If our root, this node right here, does equal to null, that means we are at the end of our list. So if we go to something like this, there's still going to be like branches coming out of this bottom, but they're going to point to null values. And that is the way that we would be able to tell if this is a null, meaning it's at the end or not. We know we want to print out the root first, so we'll have a system.out.print line where we're going to print the root.data. This gets us the value at this root, and this is a variable from our class int tree node. We have our public int data. You might want to make these private and then have getters and setters in here, but for now this is totally fine. We have our root data right here, and then we'll just add a space and then change this to print so that it would print all on the same line. So we have this root data being done. After this, we want to go to the left. So going to the left, we're going to want to make a recursive call to our print order, and then we're going to want to pass in our left value. How do we do that? Remember, this root is an int tree node, and so a part of this class is having a left variable. So we can pass in that left variable by doing root.left. That's going to give us that variable. Every time this runs recursively, it's going to mark this, even if it's left right down here, it's going to mark it as the new root. So that's how we would continuously go down our tree. We can also do a print preorder and then pass in a root dot right, and that'll give us the right for this one. So looking at this code, we have data left, right. If we were to do a tree, so looking at this, we would print this root, then we would go to the left. Print this root, go to the left. Print this root, go to the left. Print this root. Now we would go to the left again. Now because the next ones are null, it's going to go back into our recursion and then it's going to start printing to the right. And that's because we've already printed the root, we've gone to the left, so now we need to go to the right. And it's going to unwind recursively. So it will check the previous nodes right. And that's how we would write a print order for this public void print order. Let's do this as well for Inorder. I'll copy and paste this down here so that you can see just how similar this is going to be. First, we're going to change the name to print in order. I'm going to change this name down here as well to print in order. We're still taking our int tree node root as parameter and we're passing in some overall roots here. This is a good starting point. The if root does not equal to null, we're going to want to keep that, and then we can look in here and make the necessary changes. For in order, if you don't remember, it's going to be a left, and then you look at the root, and then you look to the right. So what we need to do is cut this out and paste it in front of our root. We have this root.left, then we print out the root data, and then we print out the right. And this is awesome because if we look at in order, remember we go to the leftmost first and then the root. So we're going to go all the way down to the left to all of these. We come to the end, now it's null. So we have to go back up using recursion and then we'll print our root. Now this is going to be the current root. We go back up again and this is going to be our current root. And then we look to the right. That's going to print this one. We have no left or right for this, so we're going to go back up here. We would print this, nothing to the right, and go back up, and so on and so forth. So that is our in order. We look at the left, we print out the root data, and then we print out our right. And then post order would be the same exact thing, except we would go left, right, and then print out our root data. If you have any questions about the code for in order, quickly just went over post order and print preorder as well, leave a comment below. And if you want more Java binary tree stuff, check out the playlist link below the like button. If you want to practice some problems, we have a huge playlist on all these practice problems from Practice It, and it's on the channel.